What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Checkpoint 2, Domain Deep Dive Retrieval Challenge. Let's get into it. You're 10 minutes into the exam. A question mixes DynamoDB partition key design with KMS audit trails, and for a second you freeze. The reason is simple. You practiced each topic in its own neat box, but the exam never asks them that way. By the end of this video, you'll have trained your brain to jump between domains the way the real test does. This is Checkpoint 2 of the Amazon Web Services Certified Data Engineer Associate course. No new material today, just the second third of the curriculum, interleaved on purpose. 15 questions, 6 rounds, and a stopwatch in your head. If a question feels uncomfortable, that discomfort is doing the work. Retrieval under pressure is what turns short-term recognition into the durable memory you actually need on exam day. Quick justification before we start. Blocked review, doing all your DynamoDB questions, then all your security questions, feels productive in the moment, but it falls apart when topics shuffle and it matches no real exam. Interleaved retrieval flips that. You jump from security to operations to ingestion and back to security. It's harder during practice, but studies by Roediger and Karpik show roughly 30% better long-term retention with interleaved practice. And it matches how the exam actually feels when you sit down. Every question follows the same rhythm. First, I pose the scenario and you read it carefully, watching for qualifier words. Then a pause, about 3 seconds, where you commit to an answer in your head, even if you're not sure. Then the reveal of the correct option. And finally, an explanation of why the wrong options are wrong, because that's where most of the learning actually happens. Round 1, DynamoDB. 4 questions, and some of the traps in here have a 60 to 70% wrong answer rate in practice tests. Try each one cold before you look at the recall map that follows. Here's the recall map, 4 quadrants and 1 counterintuitive detail in each. Partition keys. The surprise is that partitions split but never merge, so a bad key haunts you forever. CDC. The surprise is that Kinesis gives you a year of retention but loses the ordering stream's guarantees. DAX, the one that catches people. Transact get items bypasses the cache even though transact write items go through it. And analytics. Scanning DynamoDB for BI burns capacity every time. Let the diagram carry the rest. Question 1. A global events table uses country code as the partition key. 70% of writes target the United States. The team provisioned 50,000 write capacity units but is still throttling. What is the root cause and fix? Option A, throughput is genuinely exhausted, so increase provisioned write capacity above 50,000. Option B, hot partition on US, so shard the key as US 0 through US 9 to distribute writes. Option C, use DAX to absorb the write spike to the US partition. Or Option D, switch to on-demand capacity to remove the throttling. Take a moment to think. The answer is B, each partition caps at 1,000 write capacity units regardless of what you provision at the table level. A country code of US funnels every US write into one physical partition, and that one partition is the bottleneck. Write sharding spreads those writes across 10 partitions. Option A doesn't help because the limit is per partition, not table-wide. DAX is a read cache, useless for writes. And on-demand uses the same partitioning model, so the hot key still bottlenecks. Question 2. A team needs to replay 48 hours of DynamoDB changes to seed a new open search index and feed 3 downstream consumers. Which CDC option fits? Option A, DynamoDB streams because it guarantees ordering for the open search sync. Option B, Kinesis data streams for DynamoDB with longer retention and more consumers. Option C, a DynamoDB on-demand backup restore into OpenSearch. Or option D, a nightly full table scan loaded into OpenSearch? Take a moment. The answer is B, 2 requirements eliminate DynamoDB streams immediately. The 48-hour replay exceeds its 24-hour retention, and 3 consumers exceed its limit of 2. Kinesis data streams for DynamoDB gives you up to a year of retention, and supports up to 20 enhanced fan-out consumers per stream, which easily covers 3. The trade-off straight from the docs is no ordering or deduplication guarantees, which the client has to handle. Backup restore captures a point in time, not ongoing changes. A nightly scan misses real-time changes entirely. Round 2, what's the one thing most people get wrong about EMR Spot? You'll find out in question 4. Before that, a heterogeneous migration question that hinges on the order you run SCT and DMS. 2 questions, both from episode 13. Quick refresher before the question: master on Spot will kill the entire cluster the moment it gets interrupted. Core on Spot risks losing HDFS blocks because core nodes store data. Task on Spot is safe because task nodes are stateless compute only, and using a price capacity optimized strategy across multiple instance types keeps interruptions rare. The default answer in any cost question, then, is master on on-demand or reserved, core on on-demand, task on Spot across 5 or more instance types. And if you can move storage to S3 with EMRFS, you decouple storage from compute entirely and open up even more flexibility. Question 3. NexaRetail is migrating an on-prem Oracle warehouse to Aurora PostgreSQL with minimal downtime. Which sequence is correct? Option A, DMS alone with full load plus CDC because DMS auto-converts schemas. Option B, SCT to convert schema and PL/SQL, then DMS with full load plus CDC. Option C, Snowball Edge to ship Oracle dumps then import into Aurora. Or option D, an AWS Glue ETL job reading Oracle JDBC and writing to Aurora. Take a moment. The answer is B, Oracle to PostgreSQL is heterogeneous. The source and target engines are different, so you always need SCT first to convert the schema and the stored procedures from PL/SQL into PL/PGSQL. Then DMS moves the data with full load and CDC for near zero downtime. Option A is the most common trap, but DMS does not convert schemas on its own. Snowball is offline and cold, wrong for minimal downtime. And Glue ETL is for analytics integration, not transactional database migration. Question 4. A long-running EMR cluster with HDFS storage needs to cut compute cost. Which Spot strategy is correct? Option A, master and task on Spot, core on on-demand. Option B, core and task on Spot, master on on-demand. Option C, only task nodes on Spot, master and core on on-demand. Or option D, all 3 node types on Spot with diversified instance types. Take a moment. The answer is C, the scenario is very specific. HDFS storage means the cluster keeps data on core nodes, so a Spot interruption on a core node loses HDFS blocks. Master on Spot is even worse, it terminates the cluster. So only task nodes are safe here. Option A puts master on Spot, which is the fatal mistake. Option B puts core on Spot with HDFS, which loses data. Option D combines both failures. If the scenario had said EMRFS on S3 instead of HDFS, core on Spot would be acceptable, but with HDFS, never. You're halfway through. Security now, and this is where most candidates drop points on the real exam. 3 questions coming up on encryption choice, VPC endpoint type, and how you rotate database credentials. Before the question, 1 fact worth re-anchoring. From the Amazon Web Services S3 documentation, Using a bucket-level key for SSE-KMS can reduce KMS request costs by up to 99%. That single setting turns SSE-KMS from a per-request budget burner into a viable default for high-volume workloads. Keep that in mind for the next question. Question 5. A HIPAA-regulated workload writes to S3 and requires per-key access policies, key rotation, and an audit trail of every key use. Which option fits with the lowest cost overhead? Option A, SSE-S3, encryption is on by default and free. Option B, SSE-KMS with a customer-managed CMK and S3 bucket keys enabled. Option C, client-side encryption with a key stored in parameter store. Or option D, SSE-KMS with the AWS managed key, no bucket keys. Take a moment. The answer is B. The requirements name 3 things only KMS delivers: per-key access policies, key rotation, and a CloudTrail audit of every key use. So SSE-S3 is out, it has none of those. The cost concern is handled by enabling S3 bucket keys, which cuts KMS request charges by up to 99%. The AWS managed key gives you less control over policies, and skipping bucket keys leaves the cost problem unsolved. Client-side encryption works, but adds key management complexity for no benefit here. Question 6. A glue job in a VPC needs private access to S3, Kinesis data streams, and secrets manager. What is the most cost-effective endpoint mix? Option A, interface endpoints for all 3 services. Option B, gateway endpoint for S3, interface endpoints for Kinesis and secrets manager. Option C, gateway endpoints for all 3 services. Or option D, NAT gateway for all 3, simpler and cheaper. Take a moment. The answer is B. Gateway endpoints exist for exactly 2 services, S3 and DynamoDB, and they're free. Kinesis and Secrets Manager don't have gateway endpoints, so you need interface endpoints, which cost about 1 cent per hour per availability zone plus data charges. Option C is wrong because gateway endpoints don't exist for Kinesis or Secrets Manager. Option A wastes money on an interface endpoint for S3 when the free gateway endpoint works fine. And NAT gateway data processing charges of 4.5 cents per gigabyte make option D the most expensive at any real volume. Question 7. An RDS PostgreSQL database needs credentials rotated automatically every 30 days with no application code changes. Which service is correct? Option A, parameter store secure string, encrypted with KMS free tier. Option B, secrets manager native rotation lambda for RDS. Option C, IAM database authentication tokens generated per request. Or option D, store credentials in S3 with SSE-KMS and rotate via lambda manually. Take a moment. The answer is B. Only Secrets Manager has built-in rotation lambdas for RDS, Aurora, and Redshift, and they require no application changes. Parameter Store has no native rotation, you'd have to build it yourself. IAM auth tokens work, but they require the application to request a new token per connection, which violates the no-code changes constraint. Enrolling your own rotation lambda from scratch reinvents exactly what Secrets Manager already gives you. Round 4 is monitoring from episode 15. 3 patterns to recall. CloudWatch versus CloudTrail when the question is about an audit, picking the right service from the Insights family, and the right debugging order when IteratorAge climbs on a Kinesis stream. Question 8. A glue data catalog table was deleted overnight. The security team needs to know which IAM principal performed the action. Where do they look? Option A, CloudWatch logs insights querying the glue log group. Option B, CloudWatch metrics for the glue service. Option C, CloudTrail event history or CloudTrail lake for SQL, or option D, glue job run history in the glue console. Take a moment. The answer is C. The keyword is who. Who did what to a resource is always CloudTrail every time. CloudWatch tells you how something performed, metrics and logs, not who changed it. Glue job run history only shows ETL job activity, not catalog API calls like delete table. CloudTrail lake adds SQL on top of the immutable audit log when you need to go past the 90-day default event history window. Question 9. Operations needs to identify the top 10 noisiest source IPs hitting an API in real time with no schema work. Which insight service? Option A, CloudWatch logs insights. Write a stats query grouped by source IP. Option B, CloudWatch contributor insights, real-time top-N on structured events. Option C, CloudWatch application insights, machine learning-driven anomaly detection. Or option D, container insights designed for high cardinality workloads. Take a moment. The answer is B, contributor insights is purpose-built for exactly this. Real-time top-N analysis on high cardinality fields like source IP logs insights can produce the same result. But it's an ad hoc query you run on demand, not a continuous real-time view. Application insights is for full-stack anomaly detection across application components. Wrong scope here. And container insights is specifically for container and pod metrics. It has nothing to do with IP analytics. Question 10. A Lambda consumer of a Kinesis data stream shows getRecords.IteratorAge milliseconds climbing past 12 hours of a 24-hour retention. What is the most likely root cause to check first? Option A, Lambda memory is too low, increase memory to speed processing. Option B, a hot shard from a poor partition key, throttling one shard's consumer. Option C, stream retention is too short, increase retention to 7 days. Or option D, enhanced fanout is disabled, enable it for every consumer. Take a moment. The answer is B, practitioners on AWS repost consistently report the same root cause, a hot shard from a bad partition key. Lambda processes one invocation per shard at a time, so if 80% of traffic lands on one shard, that one Lambda invocation becomes the bottleneck, and no amount of memory fixes it. Option A is the trap people fall into, scaling Lambda before checking shard distribution. Option C only buys you time before data loss, it doesn't fix the lag. Enhanced fanout helps when multiple consumers compete for read throughput, not a single lagging consumer. Round 5 covers data quality and personally identifiable information from episodes 16 and 17. 4 things in scope. The boundary between data brew and glue data quality, what Macie actually does, the glue PII transform that does the actual redaction, and lake formation row filters for multi-region teams. Re-anchor before the next question, straight from the Macie documentation. Macie produces records of the sensitive data that it finds, sensitive data findings and discovery results. Read that carefully. Records, findings, results. Nothing in there says modifies, masks, or redacts. Macie is the metal detector at the airport, not the agent who removes the knife. Question 11. A healthcare company needs to discover PHI across S3 buckets nightly and redact social security numbers from records before they reach the analytics warehouse. Which combination is correct? Option A, Macie alone, it both discovers and redacts sensitive data. Option B, Macie for discovery, Glue Studio detect PII transform for redaction. Option C, Glue data quality for discovery, lake formation tags for redaction. Or option D, comprehend for discovery, Macie custom identifiers for redaction. Take a moment. The answer is B, the scenario has 2 verbs, discover and redact, and they map to 2 different services. Macy discovers and reports findings, full stop. Glue Studio's Detect PII Transform is the tool that actually applies redact, partial redact, or SHA-256 hash actions to records. Option A is the most common trap because Macy never modifies data. Glue data quality is for quality rules, not PII discovery. Like formation hides columns from queries, it doesn't redact values inside them. Question 12. A data engineering team wants quality rules embedded in their Glue ETL pipeline with composite logic, freshness checks, and a downstream quality score. Which tool fits? Option A, AWS Glue Databrew profile jobs with built-in rules. Option B, Glue data quality with DQDL rule sets in the ETL job. Option C, Athena queries against CloudWatch metrics nightly. Or option D, lake formation data filters with quality predicates. Take a moment. The answer is B. DQDL is code first, embedded inside Glue ETL jobs, supports composite rules and where clauses, freshness checks, and machine learning anomaly detection. That's exactly the scenario. Databrew is no code, aimed at analysts with column-level rules only, and it can't handle nested types. Athena can run quality-style queries, but not inline inside an ETL job. Lake formation handles access control, not data quality. Question 13. EU analysts must see only rows where country equals UK, and US analysts must see only rows where country equals US, same Athena table, GDPR compliant. What is the least operational overhead solution? Option A, maintain 2 separate S3 prefixes and 2 separate Glue tables. Option B, use IAM policies with condition keys on the S3 object tags. Option C, lake formation row-level data filters per principal. Or option D, create Athena views per region and grant view access. Take a moment. The answer is C. Lake formation row filters are the purpose-built feature for this exact scenario. One table, one query, and each principal sees only their rows. IAM cannot enforce row-level access on data catalog tables. That's a lake formation-only capability. Splitting into separate prefixes duplicates data and breaks single source of truth. Views work for 2 regions, but they multiply with every new team and become a maintenance burden. And the phrase least operational overhead with fine-grained access on data lake tables almost always points at lake formation. Round 6, cross-domain, 2 questions, and these are the hardest of the whole checkpoint. Question 14. Compliance asks for a record of every decrypt call against a customer-managed KMS key used to encrypt S3 objects, retained for 7 years. What is the correct architecture? Option A, CloudWatch logs with a 7-year retention policy on the KMS log group. Option B, a CloudTrail trail to S3 with a lifecycle policy to Glacier Deep Archive after 90 days. Option C, Macy scanning the KMS key for sensitive usage patterns. Or option D, enable S3 server access logging on the encrypted bucket. Take a moment. The answer is B. 2 domains converge here, security and operations. KMS decrypt is an API call, and API calls are captured by CloudTrail. To retain for 7 years cheaply, you configure a trail to write to S3, then a lifecycle policy moves the logs to Glacier Deep Archive after 90 days. CloudWatch doesn't natively capture API calls. Macy scans data objects for PII, it has no role in KMS audit. And S3 server access logs cover S3 API calls only, they miss KMS decrypt entirely. Question 15. Streaming clickstream events containing email addresses must land in S3 Parquet with emails hashed before any analyst can query them. What is the simplest pipeline? Option A, Kinesis data streams to Firehose to S3 with Macy scanning hourly to flag emails. Option B, Kinesis data streams to Lambda calling comprehend, then firehose, then S3 parquet. Option C, Kinesis data streams to firehose with a Lambda transform that hashes emails, landing in S3 parquet with the glue data catalog. Or option D, Kinesis data streams to S3 raw with a data brew nightly job to hash emails. Take a moment. The answer is C. The key constraint is before any analyst can query them. Firehose has a built-in Lambda transform hook that runs inline, hashing emails before the records are ever written to S3. Analysts never see raw values. Option A fails the requirement. Macy only identifies raw emails would land in S3 first. Option B works functionally, but adds latency and comprehend cost without giving you the parquet conversion Firehose includes natively. And option D leaves raw PII sitting in S3 for hours until the nightly batch runs, which violates the rule. Time for the NexaRetail checkpoint. 4 quadrants on screen covering ingestion, security, monitoring, and quality, and PII. Here's the reflection. Pick the quadrant where you got questions wrong in this checkpoint. Now look at it and ask yourself one thing. What's the single change NexaRetail still needs there? 1 weak domain doesn't average out. 90% in 5 domains and 40% in 1 is still a failing exam. So score yourself by domain, not by total. DynamoDB, DMS, and EMR, security, monitoring, quality, and PII, and cross-domain. If security was your weak spot, rewatch episode 14 before this weekend. If monitoring was episode 15. Close the specific gap before you sit down for the real thing. Next up is the final third of the course. Performance tuning, cost optimization, the cross-service patterns that decide hard scenario questions, and the full-length practice exam. Remember that frozen moment from the start of this video, the cross-domain question that mixed DynamoDB with KMS? Next time it shows up in the real exam, you'll recognize the pattern because you've already practiced exactly this. See you in the next one. And that's a wrap on Checkpoint 2, Domain Deep Dive Retrieval Challenge. If this helped you out, smash that like button and subscribe for more. See you in the next one.